Hello everyone. Today I am going to discuss the fourth problem of Leetcode Weekly contest 304, which is longest cycle in a graph. So what we are given? We are given a graph, directed graph of n nodes, and we have to find the longest cycle in the graph. Let's say this is the graph, and then the longest cycle of the graph is the length of the longest cycle is 3. So the graph could be disconnected also. Let's say there is this could be also the case 5, 6, 7, 8. Let's say there is also another cycle here. Then the longest cycle will be of length 4. And there is also another case that the number of outgoing edges from a node is at max 1. So you can read that statement here. Where is the statement? If mm, here each node has at most one outgoing edge. So for this question, um, it is very important statement because if there is many outgoing edges from a node, there could be more than one cycle entering a node. Let's say 1 2 3 4, and there could be also cycle like that 5 1 6. Here this type of graphs are not possible because here one has two outgoing edges. One is from 1 to 2 and another one is from 1 to 6. So for my solution, this statement is very useful to me because I now I will try to explain what I have done in this problem. So let me delete this. So what I have done is this, that let's say a node is a part of a cycle. A node could be part of only one cycle. I have already explained the reason. And if a node is a part of a cycle, then the in degree of the node will be 1. Okay, so like the in degree of a node that is a part of a cycle is the number of cycles that the node is part in. So here the in degree will be 1. So what we can do is that we can do the like the Khan algorithm, what we have done, like for finding topological sort. Like let's say this is the graph 3 4 5 6. Let's say this is the graph. Then we will try to find the in degree of the graph. So let's say this will be 0, this will be 1, this will be also 1, the in degree will be 2, the in degree will be 2, this will be 1, in degree will be 1, this in degree will be 1, this in degree will be 1. So in Khan's algorithm, what will you do? We will just remove the nodes which has in degree 0, and we will try to decrease the in degree of the nodes that have a outgoing edge from the current node. Let's say the in degree of the node 1 is 0, so we will remove this node and we will decrease the in degree of 2. 1 has a outgoing edge from 2 to 2, so we will decrease the in degree of 2 to 0. Now it becomes the leaf node. Now the in degree of 2 is 0, so we will try to remove the node 2 also. And now after removing the 2, the in degree of 3 will get decreased, so 1. So now you can see that there are 4 nodes with in degree 1. So these are a part of a cycle. So now I will try to explain my code how I have done it. So let's go to my solution. So first I am trying to calculate the in degree. If ai is not equals to -1, that means that node I has a outgoing edge from I to ai. Now we'll try to increase the in degree of ai by 1. Now I am taking the array leaves. So what leaves will contain? Leaves will contain all the nodes which has in degree 0. So if in degree is 0, then I am trying to append it in the leaves. And now this is the Khan's algorithm. I think you all know. If the I will try to iterate on the leaves, and I will try to mark the leaves as visited, and if it has an outgoing edge to aj, I will decrease the in degree of aj by 1. And if the in degree of aj is 0, I will append the append aj in the new leaves, and at the end I am setting leaves to new leaves. Okay. And after that, all the nodes which are not part of the cycle is removed from the graph. I mean all the nodes will be marked as visited. So now what I will do, I will try to iterate over all the nodes, and if the current node is not visited, that means the current node is a part of a cycle. And here it is this algorithm is a pretty straightforward finding cycle algorithm. Let's say this algorithm only can be used for the nodes which are part of a single cycle. This will not be used for the nodes which are part of multiple cycles, but I have already explained that why every node is part of a single cycle only. So I have used this algorithm. So I am initializing P to AI. P is the current node, and C is the counter, the number of nodes in the cycle, and I am marking the visited of I is 1. And while let's say what I am doing is that so I am setting, let's say this is a graph 3, 4, 5 and 6. So what I am doing is that, let's say our current node is 3, so I is 3, so I am marking I as 3 as visited, and I am pointing P to 4. Okay, now I will try to iterate on the next node, next node, next node, while P is not equals to I. So the number of values, the number of like count is 1 here, and when P moves to 4 to 5, the count will get incremented to 2. Here the count will get incremented to 3, and here the count will get incremented to 4. And at the end I am storing answer equal to maximum answer comma C, because I have already explained that a graph can have multiple cycles, disconnected cycles. So at the end I am returning the answer. I think you have understood the solution. If you still have any doubt, you can ask me in the comment section. I will try to answer the question. Please like the video and subscribe to my channel. Thank you.